I'm out. Just noticed the new release of the HPE starter kits, the NVIDIA certified starter kits. Seeing a lot of interest in that, a great starter platform. What's the importance of that, and how does it lend itself to the scale that customers want to drive if they're really going to get proper adoption of AI?
Yeah, I mean, obviously, second iteration for us, and it really comes back to, it depends where you are on the AI journey. So when we engage with customers, we found that some of our customers are, they're very mature, they know exactly the tools they want, and as a result, we can help them. But there are other organizations who might want to get started on the AI journey, and as a result, want to start small. So that's why we just came with this concept of, well, what we should really have is small, medium, and large. So you've got the flexibility of wherever you want to start, and then you can scale across those platforms. And what they are is, Poly 6500, Gen 10 Plus, Proliant-based platforms, common across our customer base, and they come pre-configured, preloaded with some of the core software you'll need based on whether or not you're starting small, medium, or large. So specific configurations to really help accelerate and take away some of the infrastructure problems.
So these are certified and tested?
Yes.
As opposed to somebody, let's go and get a white box workstation and have a dabble.
Very much so.
It creates its problems, can't it?
Yeah, NVIDIA certified with both HPE and NVIDIA software where appropriate, obviously based on a specific number of configurations.
So we've got a lot of really useful information on the starter kits that sit on our Trusted Advisor website for people to have a look at. Can you elaborate maybe on a couple of instances where they might be used? Yeah,
so if you think about a couple of industry verticals, for example, so we've got some great examples in retail, which obviously is, if you think from a retail perspective, it's shrinkage, which is theft. Mm-hmm. A lot of those use cases are video based. So you need something that's capable of processing video feeds.
The camera vision.
Yes, which is more computationally intensive. Or we've got other examples in financial services where we're looking at anti-money laundering. So again, more complex transactions, serial in nature, but a slightly different workload profile. And then other examples in manufacturing where we're looking at quality control. So again, video feed based, because it's looking at, and this is where you're looking at feeds from multiple cameras, mm-hmm. To look at the quality
sensors,
of
IoT.
Yes. Other examples on the sensor base as well. So there is a difference between training of your models and running of your models, which is known as inference.
So that then leads me to the next question I've got, which is more around having to build it yourself every time. What would your recommendations be, or what would your observations be around needing to actually build it each and every time?
I've talked about Team AI. Mm-hmm. So Team AI, when a customer is going to be successful, an organization is going to be successful on the AI journey, it's all about engaging with an ecosystem of partners. And what you want in that ecosystem is either build the ecosystem of ISVs yourself. That's complex. Yeah. It'll take you time. There are lots of them. Or leverage partners who've already, like HPE, got an established ecosystem. NVIDIA have also got a fantastic ecosystem of partners. So when it comes to tackling some problems, it might well be that you could leverage the NVIDIA or HPE ecosystem to find a partner who's done it already.
And actually working with SYNNEX as well, we've got a broader ecosystem where we are also, a solutions aggregator of various different solutions. So we can bring in maybe the camera manufacturer, for example, of a camera vision solution that could be used in that retail environment with those certified kind of starter kit offerings as well.
Yeah, absolutely. What you want is a collection of partners who work so well together. And that's what we've definitely got between HPE, NVIDIA and SYNNEX, is that capability to tackle really complex customer problems, either by bringing in ISVs that we've worked with historically, that we know how to scale, we know how to deploy, we know how to integrate between us. And what that means is you mitigate some of the challenges and some of the pitfalls that you can encounter when you try to build artificial intelligence systems on your own.
What's the importance of the tools that you would use to be able to do that? What considerations would you have around those?
So the tooling landscape in the AI space is exploding. You know, the number of open source, closed source derivatives it's getting to the point where it's virtually unmanageable. So what you need is an organization like HPE, where we've got a pre-established long-term relationship with the open source community. And what we've done is we've narrowed down the plethora of choices that you've got in the open source space to a specific number some of them have got HPE backing, or they've definitely got the capability to deploy this technology. And there are a number of startups where we believe in the technology so strongly through our Pathfinder program, we're investing in them. And what that means is it means you can choose the best tools from the open source community, plug those together with some closed source tooling as well that you'll get from an ISV that will mean that you have all of the capability in what's known as your machine learning operations, your ML ops, which is how you take your AI from initial development phases through to successful deployment. Because it is like software, but there are some things that are nuanced to an AI deployment that need to be factored into how you do model construction.
And is there anything else that you would say around kind of leveraging AI at scale?
Definitely. So I think one of the things that we've seen is AI and high performance compute really started off together, but then they've diverged and AI sort of moved away from the high performance compute space much more into the mainstream. And what's happened is high performance computing thinking has begun to merge back into AI. So what is high performance compute thinking? Well, it's about experimentation. It's about scheduling. It's about running things in an efficient way. And that's what we're seeing coming back into the AI world as we start to drive at scale.
So you're seeing them merge, essentially.
Yes, from a thinking perspective. I'll explain what I mean by that. So it's not there are many, many different AI techniques that you can apply to a problem. Choosing the right one can sometimes be complex. So as a result, we're moving away from something called model-centric AI, which is how I understand, I pop the covers on it and I look and I understand the complex maths behind it that's going to make it be successful, to something called data-centric AI. So data-centric AI is actually, what do I need to understand? I need to understand the data. I don't necessarily need to understand the maths. That's what organizations are experts in, their own data. So what I need is a technique to apply lots of different AIs to my data and find out which one is going to be the most successful. And that's examples of high performance compute thinking. So that, when you can't start to combine it with the enterprise grade AI, is what's going to give you this AI at scale capability by bringing not the technology. You don't need massive high performance compute frontier style implementations to be successful in the AI journey, but you do need some of that experimental, iterative thinking in the AI space. And those are definitely disciplines that live when it comes to applying data science to your existing data. Lots of people focus on the science part of a data scientist and think about the statistical analysis they're doing, but actually 50% of their job title is data. And that's definitely why we're seeing this move towards data-centric AI and move away from model-centric AI.
And hence some of your earlier comments around data being absolute key to any successful AI project.
Very much so, very much so. If you don't have data, you don't have AI. The two go hand in hand. And it's of critical importance that you start to think about your data strategy, where your data resides, how you get access to it, how long you've had it for, how long you transform it, who had access to it. All of these things are paramount when it comes to how you're going to get your data into the right format that then allows you to construct your models.
So Matt, you've spoken about ML ops there. Can you just break it down a little bit for me just to talk around what do you mean by ML ops?
Yeah, I think we probably would need to go back to the white wall And I can draw a bit of a diagram around explaining what MLOps is and some of the key technologies that live to allow you to go from initial model and data analysis and model construction right the way through into successful deployment. So if I go and hit the white wall now. When it comes to composability of artificial intelligence construction and deployment, we should really think about it a little bit like an iceberg, because there's a significant amount that is below the waterline. So this is hidden effort and activity that we see in the AI space. And in some cases, it can detract or divert attention from where a lot of the activity and expertise needs to take place. So what we need to think about when we're building our composable artificial intelligence stack is doing that in a way that presents it as a service. This means it falls into our existing regimes that live in the as-a-service space, easing adoption and transition of existing services and allowing development communities within your organisation to leverage the type of capabilities that you're deploying in a much easier and readily implementable fashion. When it comes to deployment of the kind of tooling that your data scientists need, really they should be picking from catalogues. And those catalogues should allow them to readily deploy the types of tools that make up the workbench that they need in order to construct the models. In doing so, we simplify the making available of the tools that they need, and as a result, reduce the amount of time that data scientists are spending building out those capabilities themselves, meaning it becomes paramount from an efficiency perspective to make use of these catalogues that can be easily consumed by your data science communities. Next up, we have tools and frameworks. In order to get their jobs done, data scientists need the right tools and capabilities. And a lot of these have been constructed into readily available open source frameworks that can be used by data science communities. These need to be accessed via the catalogue, because in doing so, we take away a lot of the complexity from an open source tooling integration perspective. And in adopting integrated componentry, we allow data scientists to have the flexibility of the tools they need while integrating them into your existing security and role-based access control frameworks. Next, we need platforms, and those platforms need additional components in them in order to accelerate your AI deployments. So if you think about this from an NVIDIA GPU accelerated perspective running on certified HPE Apollo 6500 Gen 10 Pluses, meaning that you're giving your data scientists the capability to deploy their AI models in an accelerated way, thus making them more efficient and using less power, using less cooling, and producing less carbon, which means that you're allowing them to work in a sustainable fashion. The biggest piece below the waterline, which gets the least amount of attention, is data. 50% of a data scientist's job title is data. They need access to it. They need the right kind of regimes. They need to do it in a way that is controlled, auditable, and the metadata associated with the transformations that happened, why those transformations happened, who did those transformations, how long that individual held that data for, and how they securely disposed of it, as key control mechanisms that underpin data scientists' access to data. So what we really need is data scientists here, so that they're driving the right kind of framework adoption. This is where their effort and energy from an AI construction perspective needs to be using a composable set of tools. And they also need to be focused on data. Data is a critical component of AI construction, and you need multiple people assisting in the gathering and wrangling and refining of that data, making it suitable for the purposes of data science. But what we don't want data scientists to do is spend all of their time focused on integration of the components they need in order to be successful. Have them thinking about how to build models, how to use data effectively, and not how they integrate all of these different open source community products into their existing security regimes and building them into catalogs. That's not effective use of their time. Get them to use the most appropriate tools for the job.